Let me now show you the process of writing VHDL code in Quartus. So the first step is create a new folder. You can create it in your old Quartus projects folder, but I just choose to do it in the desktop. So this is my test. And now I open Quartus. I use a pretty old version of Quartus, but it's pretty much the same in the new version as well. Okay, create a new project. Next. So browse to the working directory. So I've created one in desktop, test. The name of this project will be my underscore circuit. So the name of the entity also will be my underscore circuit. It's always good practice to have this naming convention. Nothing to add. Next, Cyclone 4E, EP4CE, 115F29C7. That's the device. Select the device. Next, finish. You have already done this for the first lab, so the process is similar. Now create a new file. And this time, instead of creating a block diagram file, I'm going to create a VHDL file. So this is the place where you can write your VHDL code. Now I'm going to start writing my code. So it's library IEEE use IEEE dot standard logic underscore 1164.all. Then write your entity my underscore circuit is, give the port names. So that's A, B, C in std underscore logic. And then F will be out std underscore logic. Now you can have multiple outputs, that's fine. But in this circuit that we are dealing with, it has only one output. So put a semicolon and then end. Architecture, data flow, or you can write any other name, that's fine, of my underscore circuit is. I'm going to create a temporary signal, which is the AND of A and B. So that's std underscore logic. And then I say begin. I write temp equals A and B and F equals temp or C. The order of the statements don't matter because in VHDL, everything is executed parallelly. So don't worry about that. End. Save it with my circuit, the same name as so the name of the file should always be the name of the entity. It's a very good practice to do that. Okay, now I can compile it. Okay, the compilation was successful. Now, if you go to Tools, Netlist Viewers, RTL Viewer, you will see that a circuit is formed here. So that's A and B, or with C, which is F. So your Quartus tool is automatically going to create the logic diagram using the logic that you have written. Your synthesis tool, supposing let's say it was a very large circuit, your synthesis tool not only compiles your code, but it also applies all the Boolean logic, all the Boolean formulae and all the Boolean laws to reduce the logic so that you can generate a diagram or a circuit with minimal number of gates. The next step is to simulate the circuit. So run simulation tool, RTL. That opens up Model Sim. I use a pretty older version, but it works fine in the newer version as well. So in work, expand, simulate. So these are the objects that get created. So in your inputs are A, B, and C, and your output is F. You also got the temporary signal. So take A, modify, apply wave. You have already done this previously. Take B, modify, apply wave. Let me change some parameters here. Give it 50, cycle of 175. Oh, duty cycle of 80. And then let me give C, modify, apply wave, initial value of 1, clock period of, let's say, 350. And F will be add wave. I can also put in the temporary signal, add wave, and I am going to simulate it for 1000 picoseconds. And I hit run. As you can see, your temporary signal is going to go high whenever A and B are high. And your output is going to go high whenever C is high or both A and B are high. So that's all these cases here. You can verify it manually. If you remember, when you did your lab 1 schematic, you had to convert your block diagram into VHDL. So here we are skipping the first part where we are first drawing the logic diagram in PDF format. Here we are directly dealing with VHDL code.